this video, we're going to look at one of the trigonometric functions called the sine function, or sine x. So we can graph this function in the xy plane. So that'll be the y-axis, and this is the x-axis. And you can use values of the unit circle to graph this. So like the sine of 0 is 0. So you know that it starts at 0, 0, right? Because if you plug in 0 here, you get sine of 0. And so that's equal to 0. So you have the point 0, comma 0. So 0, 0. The sine of pi over 2 is 1. So if you do f of pi over 2, you get the sine of pi over 2. So you get 1, right? So you get pi over 2, comma 1. So at pi over 2, this is pi over 2 here, you get 1. Okay, you get 1. Then at pi, you get 0. Okay, so at pi, you get 0. At 3 pi over 2, you get negative 1, so we're down here. And then at 2 pi, we get 0 again. Okay, so the sine function looks kind of like this, or part of the sine function looks something like that. And it keeps going forever. Okay, it should keep going here. I just don't want to draw it. I'm going to stop at 2 pi. If you go backwards, if you go into the negative x, numbers that are negative, x values that are negative, here you would have negative pi over 2. Okay, then here you would have negative pi. Then here you would have negative 3 pi over 2. And then here you would have negative 2 pi. So then here you have, let's see, at negative pi over 2, you're at negative 1, so you're down here. Negative pi, you're back at 0. And then at negative 3 pi over 2, you're at 1. And then at negative 2 pi, you're here. So this is what the graph of sine looks like. It looks something like this, okay? So generally when someone asks me, what's the graph of sine look like? What does it look like? I just know it does something like that, right? It always passes through 0, 0. So that's the graph of sine. What's important about this graph? Well, first of all, it repeats. Every 2 pi it repeats. Notice this here is a mirror image of this here. So this is called the period. It repeats every 2 pi. This is one period. So the period here, the period of sine is 2 pi. So every 2 pi, the graph basically repeats. So if I were to draw it over here, it would look exactly the same. So it's a wave function it just repeats itself over and over again. You have x-intercepts at pi, 2 pi, negative 2 pi. So your x-intercepts are at x equals 2n pi, where n is an integer. Okay, where n is an integer. It's an odd function. That's really, really important for calculus. It's an odd function because it's symmetric about the origin. So if you flip it twice, you would get the same thing. So that means algebraically that sine of negative x is equal to negative sine x. That's super important. Just memorize that. Sine is odd, so you can pull out negative signs. And the range is negative 1 to 1. That's very important for the sine function. So the range is negative 1 to 1. Is negative 1 to 1. So that's the sine function. Just a quick introduction. You want to memorize it, and to memorize it, just remember it passes through 0 and then just makes a wave. You know, that's probably the most important thing you need to remember. That's it. In this video, we're going to talk briefly about the graph of the cosine function. So you can graph the cosine function on the x and y axes. So here's the y-axis and here's the x-axis. So x, y. And if we start at 0, it's easy to start there. The cosine of 0, using the unit circle, the cosine of 0 is 1. So that gives us the point 0, comma 1. So cosine starts up here. Okay, and then you have pi over 2, pi, 3 pi over 2, and 2 pi. And I have all the values memorized, so it's easy for me to graph it. But if you kind of remember where it starts, it makes it a little bit easier. So it starts at 1, and then at pi over 2, cosine of pi over 2 is 0. Cosine of pi is negative 1. Cosine of 3 pi over 2 is 0, and then cosine of 2 pi is 1. So the cosine function looks like this. It comes down like this, then it curves up, and then it comes down, and then it curves like that. So that's the cosine function. It keeps going, but I stopped here. So this distance here is 2 pi. That's called the period of the function because it's going to just keep doing that. This shape is going to keep repeating. So if I draw it over here, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, it's going to look exactly the same. So at negative pi over 2, you get 0. At negative pi, you get negative 1. At negative 3 pi over 2, you get 0. And at negative 2 pi, you get 1. So if you graph it, it looks something like this, and then it curves down like this, and it comes up, and then it curves like that. So that's the cosine function. So the point of this video is that if someone says, hey, what's the cosine function? Say, oh, cosine x. Well, that starts at 1, and it just does something like that, right? Whereas someone said, hey, what's the sine function? Well, sine starts at 0, and it just does something like that. So that's the main idea. You can get specific points by thinking about the unit circle. And I guess that's the most important thing. It's an even function. It's an even function because if you flip it across the y-axis, you get the same thing. That means it eats negative signs. So the cosine of negative x is equal to the cosine of x. So it eats the negative signs. And the range is negative 1 to 1. So the range is negative 1 to 1. And I think that's good for now. That's it. Let's talk about amplitude. So amplitude. So we're going to look at two functions. We're going to look at a sine x, and then we're going to look at a cosine x. Okay. So normally the range of sine and cosine, the range of both of these functions is the same. It's negative 1 to 1. That's the range of sine and cosine. So they're trapped between negative 1 and 1. And so when you multiply by a number, what it does is it affects the range, and then it affects the range only. So in this case, we'll say the amplitude is equal to the absolute value of whatever number you see there. Okay? And that will affect the range. And in this case, the range is going to be bracket negative absolute value of A, absolute value of A. Let's look at some examples, just so you see the idea, and then we'll do some examples of finding the amplitude. So say we had like y equals cosine x. See, cosine of 0 is 1. So it starts at 1, and it goes down to negative 1. So it does something like this. All right, that's the cosine function, and it does the same thing over here. Something like that, right? That's cosine. So the range is negative 1 to 1. So if you were to look at, say, 2 cosine x, what that does is, so here you have negative 1 to 1, so your a here is 2. So it's basically like you're taking the number and just multiplying it by these, right? And that'll give you negative 2 to 2. Okay, negative 2 to 2. So in this case, the graph, so here's 2, and here's negative 2. Starts at 2, and then it just goes all the way down to negative 2, and it comes back up, etc. And same thing on this side. So in this case, it just makes the function go up and down higher because it's 2. If it was like 1/2, it would make it go up and down less, right? So it just affects the range. Let's do some examples of finding the amplitude so you see how it works. It's really easy. So let's look at y equals negative 3 cosine x. Well, in this case, a is negative 3. So the amplitude in this case is the absolute value of that, so it's just 3. So it's always positive, okay? The amplitude is always a positive number. Say we had 1/4 sine x. In this case, the amplitude would just be 1/4, right? Because you just make sure it's positive, and it's always this number. So to find the amplitude, it's always that number, and just make sure it's positive. And what does it do? It makes the function go up and down more, or it makes it go up and down less, depending on whether it's bigger than 1 or less than 1. That's it. Let's talk about the periods of sine and cosine, so period. So we know that both sine and cosine have period 2 pi. So here we're going to look at two special cases. We're going to look at sine bx, and we're also going to look at cosine bx. So two functions. I call them both f of x. I guess it doesn't really matter. So the formula for the period, whenever you have a number in front of the x, it's just 2 pi over that number. So 2 pi over b. So if you just had sine x, there's a 1 here. So it's 2 pi over 1. So that's 2 pi. So everything is good and the world does not end because the period of sine and cosine is 2 pi. So this has to agree. This formula has to agree with what we already know. So let's do some simple examples of finding the period. It's really, really easy. Say we have y equals sine 3x. So in this case, your b is 3, and so the period here would just be 2 pi over 3. That's your period. Okay? And what that does is it makes the period smaller in this case, right? So 2 pi over 3 is smaller than 2 pi. So that means that the graph of sine is traced out faster. Okay? So it repeats every 2 pi over 3 instead of every 2 pi. So it's traced out 3 times as fast. That's a kind of a cool concept from something else. But whenever you have a 3 there, it's traced out 3 times as fast. So if we had cosine 5x, then the graph of cosine is traced out 5 times as fast, right? Kind of just some extra knowledge. So b is 5, so this would be 2 pi over 5. Whoops, 2 pi over 5. That would be the period. Now, if you had something like sine 1/3 x, that's a little bit different. Then in this case, it gets traced out slower. So the period would be 2 pi over 1/3. So that's 2 pi times 3 over 1, because division is multiplication by the reciprocal. So then here we get 6 pi. So to find the period, all you do is you take 2 pi and divide it by the number in front of the x. So that's it. So here we're going to talk about the phase shift for sine and cosine. So we have y equals sine of x minus d, and then we have y equals cosine of x minus d. And so in this case, we're going to say that d is called the phase shift. So the phase shift is d. And basically, this is just a horizontal translation or transformation or shift. We're shifting the graph left and right. So whenever you have a positive value, you're going to go right. Okay, so it's a right shift. Okay, and if you have a negative value, it's a left shift. Okay, and so let's look at some examples. It's pretty easy. Say we had y equals sine of x minus 3. So this is a right shift. If you remember from like other math classes, whenever you subtract the number from the x, you think it's left, but no, it's right. So we're going right 3 in this case, right 3. And so the phase shift here is d equals 3, right? Because it's x minus d, so your d is 3. Let's look at another example so you see how this works. Say we had y equals cosine of x plus 2. So a couple ways to do it. Method 1 is using your previous knowledge. Whenever you add a number to the x, it's actually a shift left. So we're going to go left 2. We're going to go left 2. So in this case, d is negative, right? D is negative 2 because we're going left 2. You can think of it that way. Another way is just using this formula up here. So you can think of this as x minus negative 2. Therefore, d is negative 2. And then another way is just switch the sign. That might be the easiest way. So whenever it's x minus 3, it just becomes a plus 3. If it's x plus 2, it becomes a minus 2. Let's do another one. Check this out. Sine of x minus 4. And then one more. Cosine of x plus 8. So the easiest way to find the phase shift in both cases, I guess, is just switch the sign, right? So if it's a minus, you put a plus. And if it's a plus, you put a minus. And that's it. That's how you find the phase shift. So just maybe switch the sign. That might be the easiest way to go. So a phase shift takes the entire graph and shifts it left or right. And to find it, again, all you do is just switch the sign. That's it. In this video, we're going to put everything together. We're going to talk about phase shifts, amplitude, period, and also vertical translations. So we have, say, y equals c plus a sine, parentheses, b x minus d, parentheses. So when we have something that looks like this or something that looks like this, so I'm going to write the same thing except with the cosine function. So b x minus d, parentheses, parentheses. So using all of this, we have some stuff. So c here is the vertical translation. So vertical translation. And the absolute value of a, that's the amplitude. And the period, we talked about this before, but the period here is 2 pi over b. And then the phase shift is d. So whenever you have things that are in this form, like this or like this, these are the answers to the vertical translation, amplitude, period, and phase shift. Let's do an example. I'll start one over here on the left so you can still see everything on the same screen. So we're going to find all of this stuff. Say we had y equals -4 sine of 2x minus pi. And we're going to find all of these things. Now, in this case, the function is not in the form that we want it in, because you'll notice here it's b parentheses x minus d. Here we have 2x minus pi. So we're going to rewrite it to put it in the proper form. So to do that, so we have -4 sine. We're going to pull out a 2 here. So it's 2 parentheses x, and we're factoring out a 2 from the pi. So that's minus pi over 2. You say, what? Yeah, check it out. If you do 2 times pi over 2, the 2's cancel, so you get pi back. So it's okay. So now we can identify everything. So there is no vertical translation here. There is no c, right? You can think of it as +0. So the vert trans, I'll call it vert trans, the vertical translation is 0 in this case. That's the vertical translation in this case. Let's see, the period. To find the period, you just do 2 pi over b. So this is your b. So it's 2 pi over 2. So that would be pi. Okay, that would be pi. Okay, what else can we find? The phase shift is easy now. The phase shift in this case, well, you just switch the sign here, right? It's a negative pi over 2, so it becomes a pi over 2. Piece of cake. And what else? What else can we find? So we did the vertical trans. Oh, the amplitude. We haven't done the amplitude. So the amplitude, you just take the absolute value of this number. So it's the absolute value of -4. So it's 4. So that's your amplitude. So I think we found everything. We could also find the range. Let's do that for fun. So to find the range, remember what's happening here is initially the range is -1 to 1. So you're multiplying by -4. So it's like you're multiplying these numbers by -4. So basically it's going to become 4 -4 or -4 4. So your range is going to expand. In this case, it should be -4 to 4. That's it for now. I'll make some more videos with more examples of how to do all of these things. That's it. In this video, we have a trigonometric function, and we're going to find the amplitude, period, phase shift, vertical translation, and the range. So the general formula that we're going to use to do that is the following. So y equals c plus a times the sine of b parentheses x minus d. So when it looks like this, you can find various things. So for example, c here is the vertical translation. So vert translation. And the absolute value of a, that's called the amplitude. So I'll just put amp. And the period is equal to 2 pi over b. So the period here is 2 pi over b. And then the phase shift, that's little d. Okay, so let's go ahead and find all of these things for this function. So maybe we'll start by rewriting our trig function in a way that fits this form that's in the formula. So the c is 0, so that's not there. So we have -4 sine. And what we can do is we can pull out a 2, you see, because here there's a parentheses and an x minus d. So we want to create that parentheses. So I'll pull out the 2. Then we have parentheses x. And then we're going to have something here. Looks like pi over 2. And that should work because if you multiply 2 times pi over 2, the 2's cancel, right? And so you just get 2x minus pi, which is what we have up here. All right, so now from this, we can write all of the answers down. Let's see. So I guess first the vertical translation. I'll just put vert trans. That's going to be 0, right? Because c is 0. It's not here. It's non-existent. Okay, so the vertical translation is 0. All Or how about the amplitude? Well, that's the absolute value of negative 4. So the amplitude is just 4, right? Because the absolute value of negative 4 is 4. All right, what else do we have? Let's see. The period. So the period is 2 pi over b. So here b is 2. So the period, I'll write it over here, is simply 2 pi over 2. So the period is just pi. So the period in this problem is equal to pi. So the period is pi. Good stuff. And what else? Oh, the phase shift, right? The phase shift. That's our little d. And where is little d? It's right here. Here's our little d, pi over 2. So the phase shift is pi over 2. And the last thing we'll find is the range. This is perhaps the hardest of all. So to find the range, the way I do it is I start by thinking about just the range of the pure sine function. So if it's just sine, it just goes up and down between 1 and negative 1. So if it's sine, x is between 1 and negative 1, or rather the y value is between 1 and negative 1. Right? That's the range for sine. Here it's being multiplied by negative 4 though, so the amplitude is 4, so it's going to take it from negative 4 to 4. So the range in this case would be bracket negative 4, comma 4. So this number here directly affects the range. So if there was a 2 here, it would be negative 2 to 2. If there was a 3 here, it would be negative 3 to 3. So I hope this video has been helpful. And remember, all you need to do is memorize this formula and then just find everything. That's it. Hi everyone, in this video we have a trigonometric function and we're going to find a bunch of stuff like the range, the amplitude, the phase shift, the vertical shift, and the period. So to do all that, we need to know the formula. So the formula is, or the general form, is the following. So it's y equals c plus a, and then here it's cosine, and then parentheses b times x minus d. So that's the general form that we need this to match. And using this, we know a bunch of stuff. So we know that c here is what's called the vertical translation. So that's the vertical trans. The absolute value of a is called the amplitude. So I'll just put amp. The period here is equal to 2 pi over b. And then the phase shift, I'll just put ps, is equal to d. Okay, so in this problem, we just have to rewrite what we have to make it fit this form here, and then we can get all of the answers. So let's go ahead and do that. So we'll start by writing it as y equals. And if you want, you can put the 0 here. Why not? Let's be silly. Let's put it there. Sometimes it's good to be silly, right? So 0 plus 3 cosine. And then we can pull out a 4. So 4 parentheses x plus, and then pi over 4. Parentheses, parentheses, right? So now we've made it fit this form that is down here. Okay, so let's go ahead and find everything. So the vertical translation is 0. So I'll put that up here. I'll call it VT just to be cool. Vertical translation is equal to 0. The amplitude is the absolute value of 3. So 3 is just 3, right? Its absolute value is 3. So the amp is going to be 3, right? You see the A is 3, so same thing. What else do we have? The period. The period is 2 pi over b. So here the b is 4. It's right here. So it's 2 pi over 4, which is pi over 2. Right? Because 2 goes into 4 twice. And then the phase shift, here's where it gets sneaky. So this is the reason I pulled out the 4. You see here it's minus d, and the phase shift is d. So you just switch the signs. So in this case, the phase shift is negative pi over 4, right? It's important to switch the sign. Look, there's a negative d here. It becomes a positive d. There's a positive pi over 4 here. It becomes a negative pi over 4. And last but not least is the range. So to find the range, always start with the range of cosine. So cosine by itself has a range between negative 1 and 1. So the y value is between negative 1 and 1. But then when you multiply it by 3, it's going to change from negative 3 to 3. So the range here would be negative 3 to 3. So I hope this video has been helpful. That's it. In this problem, we're going to find various things for this function. So first, let me point out the standard or general form. So that form would be y equals c plus a sine, parentheses, b times x minus d. So whenever things are written in this way, we can find various things for the trig function. So for example, c here is the vertical shift. So 1/2, that's our vertical shift, so vert shift, or vertical translation. So that means it's going to take this function here and add 1/2 to it. So it's going to shift the whole thing up by 1/2. The number here, that's going to be a. And so we know from a formula that the amplitude is equal to the absolute value of a. So in this case, it's just the absolute value of 1. So the amplitude is equal to 1 in this case. The phase shift is d. So the phase shift is d. So d is the phase shift. So to find the phase shift, what you do is you switch the sign here. So that becomes negative. So negative pi over 4. Always just flip the sign to find the phase shift. So that's the phase shift. Let's see, what else can we find? Oh, the period. To find the period, the formula is 2 pi over b. Okay, so 2 pi over b. So your b here is 2, right? It's 2. So you just divide it by 2, okay? So it's 2 pi over 2. So you get pi. So that would be your period. The period is pi. Okay, and then lastly, let's find the range. So to find the range, you kind of have to think about it a little bit. So the amplitude is 1. So that means ignoring the vertical shift, you'd be looking at a range of negative 1 to 1. So when you add 1/2 to that, you're adding 1/2 to each of these. So that means that your range would be, let's see, negative 1/2 to 3/2, right? Because you're adding 1/2 to each of these numbers. Negative 1 plus 1/2 is negative 1/2. And then 1 plus 1/2 is 3/2. So in this video, we found the vertical shift, the phase shift, the amplitude, the period, and the range of this trig function using this form and various formulas. In this video, we're going to find the amplitude, period, phase shift, vertical translation, and the range of this trigonometric function. So before we do that, I'm going to write the formulas down. So the general form or standard form of this function is c plus a cosine parentheses b times x minus d. And I'll go ahead and write down all the formulas for you. So the amplitude, I'll call it amp, is equal to the absolute value of a. So let's go ahead and find that. So a here is 1. Okay, so a is 1. And so this is the absolute value of 1, which is equal to 1. So the amplitude is 1. To find the period, okay, the formula for the period is 2 pi over b. So in this case, b is 3. So it's just 2 pi over 3. Boom, there it is. To find the phase shift is d. So in this case, d is just pi over 6. So that's your phase shift. It's pretty easy. I just switched the sign. So if there's a negative, it becomes a positive. If this was positive pi over 6, this would be a negative pi over 6 down here. The vertical translation is your c. So it's negative 5/2. So it's c. So it's negative 5/2. That means we're going down 5/2 because it's negative. If it was positive, you'd be going up 5. Aha. So now to find the range. So here's what we have to think. So if it was just the range of cosine by itself, it'd be negative 1 to 1. Okay. Then we consider the amplitude. So the amplitude here is 1. So we multiply all of these by the amplitude, so it's still the same. If this was like a 2, this would be negative 2 to 2. The next step is to take into consideration the vertical translation. So we're taking these numbers and going down 5/2. So you want to think of these as numbers over 2. You want to think of it like this, and then subtract 5/2 from each of these numbers. So let's see, so negative 2/2 minus 5/2 is negative 7/2, and then 2/2 minus 5/2 is negative 3/2. So that there would be the range. That's it. Hi everyone, in this video I'm going to show you how to graph pretty much any sine function. So I've picked one that is not super easy, so let's try to see if we can graph it. So the first step you do when graphing one of these functions is you take whatever is here, okay, and you set it between 0 and 2 pi. So step 1, take whatever is here, I underlined it in yellow, and set it between 0 and 2 pi. So let's do that. So here we have 2 pi, and then here we have 0, okay? Then you want to solve for x. So if we divide everything by 2, so divide by 2, divide by 2, divide by 2, you end up with 0 less than or equal to x plus pi over 4 less than or equal to pi. And the last step is to subtract pi over 4 from all of the sides. So minus pi over 4, minus pi over 4, minus pi over 4. You can think of pi as 4 pi over 4. So what happens is you end up getting negative pi over 4 less than or equal to x, right, because these cancel. And then 4 pi over 4 minus pi over 4 is 3 pi over 4. So step 1 has been done. So again, whenever you want to graph any sine function, the first step is just take this and just always set it between 0 and 2 pi and then solve for x. All right, the next step is to compute what I like to call delta x. Okay, so step 2 is to compute delta x. And it's always going to be upper minus lower divided by 4. So I'll explain what that is in a second. So upper minus lower, and then you want to divide all of that by 4. So this is your upper, and this is your lower. So you can think of it as right minus left if you want. So this is 3 pi over 4 minus negative pi over 4, right? Upper minus lower, and then all of that is divided by 4, right? So always works. It's always the biggest minus the smallest. Let's see what happens here. This is minus and minus is plus. Oh, I see. So this is 4 pi over 4 over 4. So this is just pi over 4. So our delta x is equal to pi over 4. That's our delta x. All right, so let me just scroll down, and I'm going to rewrite the function because we lost track of it in this mess. So f of x is our original function, and it's 1/2 plus, and let me scroll up because I lost it, 2 plus sine 2x plus 4. Okay, so 2, then sine, and then 2, and then x plus pi over 4. Okay, that's it there. Beautiful stuff. So again, step 1, let's recap what we've done. We took this piece here, okay, and we set it between 0 and 2 pi. We solved for x, and we got here. Then step 2, do upper minus lower, so it's just this one minus this one divided by 4, okay. Step 3, we're going to draw a little picture, right? So in our little picture, we're going to use our interval. So our interval started at negative pi over 4, and it goes to 3 pi over 4. So I'm going to graph that down here. So we have negative pi over 4, okay, and then here we have 3 pi over 4, right? We got these from what we did just a few seconds ago, right, when we solved for x. And now you just keep adding delta x. So when you add delta x, pi over 4, to negative pi over 4, you get 0, okay? If you do it again, you get pi over 4. Do it one more time, you get 2 pi over 4, okay? And 2 pi over 4 is the same thing as pi over 2. Do it again, you get 3 pi over 4. So add pi over 4, add pi over 4, add. So just keep adding pi over 4. Add this, pi over 4, and you get these numbers here. These are the numbers that we are going to plug in to our function and plot, and then we're done, okay? And you might say, well, why can't you just pick any numbers, like 1, 2, 3, 4, 5, and plug them in? You can, but we're doing this without a calculator, right? We're doing this from scratch, like the pros do it. And what this is going to do is it's going to give us really nice, easy angles to evaluate. So I'm going to scroll down, and again, I'm going to write down our function one more time because I keep losing it. So f of x, and we said it was 1/2 plus 2 sine. I think I have it memorized now, 2x plus pi over 4. And then that's it there. Is that the right one? Yes, it is. Okay, so let's plug in all the numbers, so just one at a time. I'm going to write a little bit smaller now. So let's see. So let's look at f of negative pi over 4. Okay, you've got to be very careful here. This is where it's easy to mess up. This is 1/2 plus 2 sine. And our x is negative pi over 4. So when you add it to pi over 4, it's going to be 0. So it's going to be sine of 0, okay? Because it's negative pi over 4 plus pi over 4. Sine of 0 is 0, so this is just 1/2. So our first ordered pair is going to be negative pi over 4, comma 1/2. That's our first ordered pair. I'm going to put this in a box. This is called an accomplishment. Let's do f of 0. So f of 0. Okay, plugging in 0, we're going to get 1/2 plus 2 sine, and let's see, 0 plus pi over 4 is pi over 4, times 2 is pi over 2. Skipping steps here to save room, right? So putting a 0 for the x, it's going to be pi over 4, right? Because 0 plus pi over 4 is pi over 4, times 2 is pi over 2. We get the sine of pi over 2. Sine of pi over 2 is 1, so this is 1/2 plus 2. That's really 4/2 plus 1/2, which is 5/2. Lots of math. So the ordered pair here is 0, 5/2, right? 0, 5/2. Put that in a box. Let's look at f of pi over 4. So f of pi over 4 is 1/2 plus 2 sine. And we're plugging in pi over 4, so we get pi over 4 plus pi over 4. It's pi over 2, right? Because it's 2 pi over 4, which is pi over 2. Times 2 is pi, so we get sine of pi. Sine of pi is 0, right? It's the y-coordinate at pi, which is 0. So this is going to be 1/2, right? So the ordered pair here is pi over 4, comma 1/2, right? Almost there, almost there. 2 more points. This is the grunt work, right? And it just takes practice. Notice all the angles are easy. 0, pi over 2 pi. It's all the easy ones. You're never going to get like a pi over 6 here or a pi over 3 with this method. It's always the easy angles. That's why I think this is the best method in the world for graphing sine and cosine. Let's do f of pi over 2. So f of pi over 2, it's 1/2 plus 2 sine, and then we have 2. And we're plugging in pi over 2. Uh-oh, it's a little bit harder. Pi over 2 plus pi over 4. Pi over 2 is 2 pi over 4. 2 pi over 4 plus pi over 4 is 3 pi over 4 times 2. I'm going to write it. 3 pi over 4 is too much math to even speak. This is going to be 3 pi over 2. The sine of 3 pi over 2 is negative 1. So this is 1/2 minus 2. So this is negative 3/2, right? Because it's 1/2 minus 4/2, which is negative 3/2. So this is pi over 2. And then negative 3/2. I'm skipping a lot of steps in the computations, and I'm just saying them in words just to save room, right? I want to have all these points because we're almost done. The last one is f of 3 pi over 4. So f of 3 pi over 4, it's going to be 1/2 plus 2 sine. Then we have 2. Okay, so let's see. 3 pi over 4 plus pi over 4 is 4 pi over 4, which is pi. So we get sine of 2 pi. Sine of 2 pi is 0, so we just get 1/2. So here our ordered pair is 3 pi over 4, comma 1/2. So there are our numbers, right? So let's go ahead and put everything together, right? Let's graph everything. So I think I'll squeeze it in over here. Let's be really careful. So here is our y-axis. Okay, beautiful stuff. Here is our x-axis. So there's our x, and there's our y up here. So y. And it doesn't have to be perfect, it just has to be good. So negative pi over 4 will be here, okay? And then this will be 0. And then this will be pi over 4. I'm going to go ahead and put that there. And then this will be pi over 2. And this will be 3 pi over 4. These are the numbers that we got at the beginning of the problem, right? When we subdivided our interval and this is 0. So it looks like the smallest y value is going to be negative 3/2. I'm going to use 1/2 increments. Well, maybe not. Okay, so negative 3/2 is going to be, okay, so this is negative 1/2, negative 1, negative 3/2. Why not? And this is 1, 1/2, 3/2. Okay, the first one is negative pi over 4, 1/2. That's here. Okay, there goes my symbol. So, so let me use a different color here. So this one is negative pi over 4, 1/2. That's this red dot here. And the next one is 0, 5/2. So that's actually pretty high up. So it's 1/2, 2/2, 3/2, 4/2, 5/2. That's here. The next one is pi over 4, 1/2. That's down here. The next one is pi over 2, negative 3/2. That's down here. And the next one is 3 pi over 4, 1/2. That's up here. All we do now is we connect the dots and we make some type of curve like that. And that's pretty good. That completes it. So I hope this video has been helpful to someone out there who's learning to graph sine and cosine. Remember, step one, just take whatever is here, right? You just take whatever is here and you set it between 0 and 2 pi, okay? Always, always, every single time. Then you solve for x and you get this mess here. Then you compute delta x. And then you just keep adding it, right? Boom. And then you just plug in those numbers, and then you just plot the points, and then you got it. You've got the graph, right? So that's it. In this video, we're going to graph this trig function, solution. So there's a couple ways to do this. The way I like to do it always works. So step one is you take whatever is here, and you set it between 0 and 2 pi. So you do 4x plus pi, and then you set it between 2 pi and 0, always, every single time, right? Whenever it's a cosine or a sine, you just do this first, okay? So step one, you solve this. So solve for x. To do that, we'll subtract pi from all the sides. Okay, so these cancel, so we get negative pi less than or equal to 4x, less than or equal to pi. Almost there, and now we just have to divide everything by 4. And so we get negative pi over 4, less than or equal to x, less than or equal to pi over 4. So recap. Step one, when graphing something like this, just take whatever is here and set it between 0 and 2 pi, okay? And you get this. Always works. Okay, this is going to be your lower, and this is your upper, okay? And what we're going to do is we're going to take the interval, this interval from negative pi over 4 to pi over 4, and we're going to subdivide it into equal subintervals. This is like a super powerful technique in math. So to do that, all you do is you compute what's called delta x. That's going to be the width of our interval. And it's always upper minus lower divided by 4. So you just subtract these, okay? This one minus this one and divide by 4. So that's going to be, let's see, upper is pi over 4, okay? The lower is also negative pi over 4, so it's similar. It's just negative over 4. This becomes a plus, so you get pi over 4 plus pi over 4. So you get 2 pi over 4 over 4. So you get pi over 2 over 4. So it's really pi over 2. So when you divide by 4, you really multiply by the reciprocal. So it's 1/4. So it's pi over 8. Okay, going kind of fast, but this is a long problem. So delta x is pi over 8. Okay, so very, very important. I'm going to put that in a box. Okay, I'm going to put that in a box. All right, so step one, you take whatever is here, you solve for x, you get here, then you do this minus this, and then divide by 4. Now you draw a picture. Okay, now you draw a picture. I'm going to scroll down. I'm going to rewrite our original function so I don't lose it. So our original function was y equals, I believe, let me go back and look. It was -1. Okay, -1 plus 2 sine 4x plus pi. Okay, that's our original function. So we solved for x, we found delta x, so now we draw a picture of our interval. So the lower is negative pi over 4. The upper is pi over 4. Okay, so now we got to get the numbers in between. So all you do now is you just keep adding delta x. So if you add pi over 8 to negative pi over 4, you get negative pi over 8. So how did I do that? I thought of negative pi over 4 as negative 2 pi over 8. Same thing, right? Because 2 over 8 is 1 over 4. Then you do it again and you get 0. Then you do it again and you get pi over 8. And then you do it again and you get pi over 4. Because you could think of, again, you could think of 2 pi over 4, virus protection. All right. You could think of pi over 4 as 2 pi over 8. All right. So now these numbers here, what we do with these numbers is we take these numbers and we plug them in to our function, and then we connect the dots and we're done. And that's it. So step one, take whatever is here, set it between 0 and 2 pi, solve for x, compute your delta x. Once you compute your delta x, you just keep adding it over and over again. And then you take these numbers here and you plug them into your function to get the y values, and then you just connect the dots. So this is the long part. This is the tedious part. Let's go ahead and do it. So first we're going to plug in negative pi over 4, I guess. So negative pi over 4, that's negative 1 plus 2 sine 4 times negative pi over 4 plus pi. So this is the grunt work, okay? This is negative 1 plus 2, so we're plugging in negative pi over 4 here. So that's sine, let's see, you don't want to mess up here. These cancel, so you get negative pi plus pi, so you get 0. Sine of 0 is 0, so we get negative 1. So our first ordered pair is negative pi over 4, comma, negative 1. That's our first ordered pair. So again, did that kind of fast, but you take this number and you plug it in here, and that gives you your y value. In this case, it was negative 1. So 1 down. Then you got to do it for all of them. It's a lot of work. So now we'll do y of negative pi over 8. So that's negative 1 plus 2 sine of 4 times negative pi over 8. Don't want to mess up. Plus pi. So that's negative 1 plus 2 sine, let's see. 4 goes into 8 2 times, so that's going to give you a 2 there. So negative pi over 2 plus pi is pi over 2. So you get negative 1 plus 2. The sine of pi over 2 is 1, right? So it's 1. So we get negative 1 plus 2, so we get 1. So our other ordered pair is negative pi over 8, 1. Wow, a lot of work. Negative pi over 8, 1. So I'm going to put that in a box. Okay. Now we'll do y of 0. So it's negative 1 plus 2 times the sine. So let's take a shortcut here. We're plugging in 0 here for the x. So it's just sine of pi. And sine is the y-coordinate on the unit circle. So at pi, the sine of pi is 0. Right? So this is negative 1 plus 2 times 0. So it's just negative 1. So our next ordered pair is simply 0, negative 1. Right? 0, negative 1. So I'm going to put that in a box. And 2 more and we're done. So y of pi over 8. That's negative 1 plus 2 sine. So let's see, 4, and then x, so pi over 8, plus pi. So that's negative 1 plus 2 sine. That's going to be pi over 2 plus pi, so 3 pi over 2. So on the unit circle, sine is the y-coordinate, so at 3 pi over 2 you get negative 1. So this is negative 1 plus 2 times negative 1. So you get negative 3. So our other ordered pair is pi over 8, negative 3. Pi over 8, negative 3. It's our other ordered pair. One more and we're done. We can graph this thing finally. It's a long problem, I know. Y of pi over 4. This is negative 1 plus 2 sine. So it's 4 times pi over 4 plus pi. So this is negative 1 plus 2 sine. These cancel, so you just get 2 pi. And again, sine is the y-coordinate on the unit circle, so at 2 pi you just get 0. So this whole thing here is 0. So you just get negative 1. So our final ordered pair is pi over 4, negative 1. Okay, so now we're going to put everything together and graph this. Okay, so I'm going to highlight the points we have. It's a mess. We have this one, this one, this one, this one, and this one. Okay, so I'll draw the y-axis, draw the x-axis. So negative pi over 4, that's our first x-coordinate. And then we have negative pi over 8. And then we have 0. Then we have pi over 8. And then we have pi over 4. Okay? And it looks like this is 1, this is 2, this is negative 1, this is negative 2. And I guess we do need a negative 3, right? Because this here is negative 3. So at negative pi over 4, we're at negative 1, right? That's this first one here. I'm going to use a different color. So we're here. Okay, we're here. Negative pi over 4, we're at negative 1, because this is negative 1. And then at negative pi over 8, we're up at 1. So it's going to do something like this. Okay, right there. And that's this one here. And then 0, negative 1. So that's the next one. So it's going to be down here. Okay. And then pi over 8, negative 3. That's going to be down here. Okay. And last but not least, pi over 4, negative 1. So then pi over 4, negative 1. So just carefully connect these dots and make what looks like a wave function. And that's it.